If you like the content of this video, please do press the like button and subscribe. Integration is the process of finding a function, g of x, the derivative of which is equal to the function, f of x. The function, f of x, is called the integrand, while the function, g of x, is called the integral. The elongated S-shaped symbol is the symbol of integration. Notice that c, which is the constant of integration, occurs because the derivative of a constant is 0. So, integration can be thought of as finding an antiderivative. Integration of functions is not commutative. Note that integration of a function of the form f of x by g of x cannot be performed by separately integrating the numerator and the denominator. When we studied derivatives, we had established the derivatives of some commonly used functions. We can now readily list the integrals of the antiderivatives of these functions. A common technique in integration is the technique of using substitutions. The trick is to substitute that part whose derivative is the remainder of the expression under the integral. Integration by parts is a very important technique. We have already established the product rule of differentiation, as shown in equation 1, rearranging the terms, and then integrating. We arrive at the integral form, as shown in equation 4, setting f of x as u of x, and g prime of x as v of x. We arrive at equation 5, hence, integral of two functions is the product of the first function and the integral of second function, minus the integral of the differentiation of first function and the integral of second function. Definite integrals represent the exact area under a given curve, and Riemann sums are used to approximate those areas, as shown in equation 6. Hence, the average value can be computed as per equation 7, from which equation 8 automatically follows. We now discuss various integration strategies. The first strategy is to simplify the integrand, which is the function that we are trying to integrate. For example, we can express cos square theta in terms of cos 2 theta, whose integration we can compute. The second strategy is to see if substitution will work. We have seen that before. If the integrand is a rational expression, we can try to express it in terms of partial functions, which we can easily integrate. If the integrand is a polynomial, multiplied by trigonometric, or exponential, or ln functions, integration by parts may work. If the integrand is in the form, as shown in item 5, substitution using trigonometric functions may work. If the integrand has a quadratic in it, completing the square may work. Now that you have grasped the concept of integration, and have understood the strategies of integrating, you should solve a variety of problems to master the art of integration. In the next session, we will start looking at ordinary differential equations.